What's up, guys? Corey here. Nah, just kidding. It's Galen. But hope you like the reference. Um, but instead of learning about how to play guitar, we are going to learn about reflex-dom today. And I definitely not guitar because I don't know how to play guitar, despite having owned a guitar for now quite some time. But thankfully, I have learned other things, such as reflex. And so I actually had a ton of fun getting set up for this. Definitely a lot more prep work than I'm used to doing because I figured what is the best way to sort of go about this, and I think it's just a ton of examples. That was definitely when I sort of had my breakthrough about understanding what the heck is actually going on with functional reactive programming, because it is definitely a bit of a high level, challenging concept to wrap your head around. But I think it becomes very clear when we see just simply what's happening on the screen. And so what I've done is I've set up a number of just simple examples here, separated by these little dotted lines here, which will show us all these sort of variations of how to use the reflex library and the reflex-dom library for creating sort of simple events. And so with that, I have decided to exclude web requests, time, and any JavaScript, which is not necessarily an event, but anything of that nature, to kind of focus it on the core, the core focus of what we're doing with functional reactive programming, and in particular, if we think back, um, with defining these sort of data flow diagrams. What I mean by what we're focusing on is that we'll be talking about how to edit these data flow diagrams. And so, for example, we might have, a an event which might fire and do something, but we can apply a filter to it as a simple example, and then that event may or may not happen. And so I know I had something to say here. What did I have to say? Oh, you know what? I would be quite off if I didn't start talking about behaviors, dynamics, and events. And so events kind of being the core piece of functional reactive programming. Nothing really happens without events. The last video, I'm sure you found that maybe a little boring because we weren't doing anything very exciting. We were just writing a DOM, and so I tried to keep that short. Wasn't short, but I tried. Hopefully, it was valuable. Again, let me know your thoughts. Um, so what is a behavior, a dynamic, an event? And so let's start with behavior just because there's the least going on with it. And all a behavior really is just a container for a value that cannot change. And Now, in terms of the application of all of this, I just want to be clear. Like, I think it will make a lot more sense once we get to an actual tutorial where we build a web app ourselves. I have posted a link to this tutorial, the source code, which is available right now. Um, there are other projects I have on my GitHub that might be a little easier for just wrapping your head around, um, you know, what the heck we're actually doing here. If you want to see it as a real world example, um, to have something to chew on. And anyways, so behavior just simply being a container for a value that cannot change. Um, doesn't really do much for us. It's really, there's, for example, a function which we'll talk about, and I believe it's called constant. And all it does is take any Haskell value and turns it into a behavior. Does nothing. Almost like ID, except wrapping it And what this does is not very clear when we look at just behavior, but by having a behavior that allows us to do particular things, which might be helpful for uh, our reflex application. Um, and so, I've never actually used constant in practice, but a good example of where we might use a constant is to, let's say we could use a constant to disable um, an action, because we have another function which would check the value of a behavior. And so if this was, let's say, a bool, one way we could actually make this useful is to make this guard, an event from happening, or rather gate an event from happening. And yeah, now more often in practice, behavior derives from a more interesting type, which is or interesting um, wrapper, I should say, not like 50 Cent, but like in the Haskell sense, dynamic. And so I guess I should say that all of these are kind of you wrappers in that sense. At the type level, we'd have a dynamic TA. And so, what is a dynamic? Well, dynamics are effectively the merging of an event and a behavior, which now calls into question, well, what is an event? And an event is simply an event, something that can happen in our DOM. I'm trying to think of how to define it without talking about what an event is. I mean, think we all kind of know intuitively what an event is. There's obviously events in DOM language. For example, a click is the easiest event to think of. If someone clicks, then we have we have a function that makes a button, and so if they click that button, it will fire an event. And so the user action is directly creating an event, which will propagate through our data flow. And so then that kind of sets us up to think about a dynamic. And so a dynamic is just simply the combination of these two. And if you want a further explanation, I will continue to explain, by the way. But if you want a further explanation, another great tutorial is reflex-dom in bits, which I will link to in this video. But I think I linked to it in the first video, so do check that out. I definitely recommend it. But and this is again more to augment this sort of tutorials that are out there, and in a way that's very beginner friendly. But anyways, so a dynamic is the combination of a behavior and an event, in the sense that it's not it's not exactly like a behavior, because now this value can change, hence the name of dynamic. And because it can change, we have the ability to view it as an event. So, for example, we have a function updated, which takes a dynamic and turns it into an event. And so properly, in terms of the actual types, it would be like so. And yeah, and what we'll see in practice is that most of what we're doing, jeez, my speaker just turned off and kind of scared me. Anyways, what we'll see is that most of the time we're working with dynamics and events, and there are certain cases where we want to turn a dynamic into a behavior, and so how do we do that? Well, we ask, what is the current value of the dynamic? So this value, which can be changing across time, and is really kind of, in a sense, merging side effects, you could think of it as. we want to take a snapshot of what it is at that current time. And so let's say we have a dynamic which goes from being the value of 1 to 2 to 5 to 6 to 7. I don't know where I'm getting these numbers from, or what sort of pattern that is, but maybe there's none at all. There probably isn't any at all. But let's say we get to 7, and we know this is going to continue to change. Well, we might have a number of a DOM events which we want to take a snapshot of that current of that dynamic at the current time of 7. And so once we do take that snapshot, it's kind of a permanent snapshot. And so to my understanding, this is like the most like why we have behavior is to take snapshots of dynamics. It's rare that we ever want a pure behavior. Originally, I thought this might be like, how do we, maybe a DOM element is a behavior or something, and that's absolutely not the case. I've long since been corrected about that. And, so by taking that snapshot, even though the key point is that even though the dynamic itself is changing, that dynamic that originally created the behavior, that behavior is locked in time and space. It becomes just this pure sort of, if you want to think of it as a scalar value, think of it as a scalar value. I don't know. It makes sense to me. And so that is really what we're doing here. And so, maybe the best way to think about the data flow diagram is, well, really just like any sort of diagram, like like let's see this. So, if we have it blue. So, we just have this forward propagation sort of diagram. And one node in this event propagation graph can subscribe to many others, right? Sort of like the brain analogy I made in the first video. This node can also, this node can also subscribe to this node, as well as this node can also subscribe to this node. And yeah, and even really too, actually, now we won't see how to do this in this video, but we could have this node also subscribe to this node somehow. So if it's subscribed, then the arrow is pointing towards it. I like to think of it as, and I think this is how you're supposed to think of it anyways, but as this subscribes to this, and which is why the input from this previous node will affect the output of this node. And then I guess we'll sort of create an event loop of some kind, which may not actually just continue to go off on a tangent. It might be that the value or the output, or sorry, rather the effect of this arrow here might be continually changing based on the result of this arrow. But this event, that doesn't necessarily mean that the event will fire as soon as this event fires, this event will not necessarily fire once this event fires, but based on whatever logic it has been, kind of set up with. And so it might, for example, accumulate. These arrows might represent some sort of accumulation, and that node only actually does something when it clicks. I don't know. Yeah, not liking this example compared to this diagram, but um, that means we should definitely just get started. Anyways, so let me think. Well, yeah, everything here is really defined down here. So let's start with our first example. And so this is just a really, really simple case. And I'm realizing that I should do, pardon me. I'm just going to comment that out so we can only see one on the screen. And this is a good time to speak about this before I forget. I have a Google server running, and so how I've done this is I just have a Google server set up. It's just an Obelisk project. As you can see, it's just an Obelisk project. And so what I've done is I've added some whatever programs I care about to the backend .cabal here, and that will add them to the package index. So if I cat my backend .cabal, we can see that, for instance, I have a couple of gaming libraries. Vulkan, cool library, check it out. You might have heard of it. Say as well, kind of cool, but so some libraries that wouldn't necessarily be searchable on the normal Google, I can now just go ob Google, and in a second, this is going to create a Google server, and I can listen on, or sorry, check it out on port 8080. And for example, if I want to look up a function like updated, I can find it here. Whereas if I went to just plain old Google, I believe that updated will not come up at all. Yeah, it does not. So that's what I meant to say in the other video. But yeah. Unfortunately, I am not an editing wizard and smart enough to figure out how to go back in time and change what I said. Yeah. So, right. Pseudocode not appreciated. That's what we'll get to. But so all this is going to do, if we look at it, before we see what it's going to do, let's look at our code, try to understand what the heck is going on. Yeah. So and so each of these I've wrapped in just a tiny little div, which we can see if we care enough. You know what? It didn't work the first time. I don't care. Yeah, it doesn't really even matter. And so what we have here is a button which emits a click event. And so let's go through this really quickly because yeah, I think it's important to go through this quickly. Button. And so the text is just what's going to show inside of the button. So for example, I have click me one, which is not very interesting, but this is the interesting part, is that what we are doing is we are creating an element with this element function. We are giving it the def function. I want to say keyword, but it's not a keyword. I feel like it kind of feels like a keyword, but it's definitely not a keyword. Of course, it's Haskell, so it's a function. And what does def do? So def is for default, or the default class. And so all default does, and this is it here, is define a default value for a type. And so we can say that the default of int is 0, which is very arbitrary. I guess it makes sense. So, but for well, it wouldn't be in here. What am I saying? So default of, where'd it go? Default of element, or rather, not element, but element config, right? So element is taking text. Oh, just gonna delete that. Element is taking a text for the HTML tag, and then the next argument is going to be an element config. And so element config has a default. Ignore that default. That's a little bit, definitely different. But I wonder if we can quickly find. There we are. And so we can just see that default element config just sets it to not very interesting values. We have default also recursively being called, except this time it's not going to be for the type of element config. Is always going to, and that might be confusing for if you're coming from another language, or just not comfortable with recursion. But the Haskell compiler will know that this def, the type of def is determined by the field of element config event spec, and not just the fact that in this function, def means something. And, you might be inclined to think that def means this or whatever comes in after the equals sign, but that is not the case. And again, just types. So yeah, that's element. So, but what we're doing with element, and this is the core important piece for events, is we are getting. So this returns a tuple wrapped in our monad, and we are just grabbing this here. And so this A would be, for example, if we at the end of our inner monad had pure 1, then the type of this would be an int, and the value would be 1, which is not really interesting, but important to dissect away. This is what really matters, because having this element here now allows us to do DOM event click E. And so DOM event, and right, this is how we're doing it. And then DOM event click E. And what's interesting is that if we look at, and this is really nice how it shows event T unit here like that. It might be a little more confusing if we look at the fact that that's not exactly what it returns. And, so we will do more on that. That's actually the next example, where we will understand a bit more about what is going on here. But it just, for now, we can just think of it as allowing flexibility. And here, we are using that flexibility to build a DOM event which responds to a click. And so now what this is saying is that for the space of this button element, right, we could enlarge the element of the button. Well, actually not really through this function, but we could build an element and do this exact same thing that makes a massive button that takes up like half of the page. And if we click anywhere in that DOM space, then the click will be received, and we will be activating an event, which may have some consequences. Yeah. And so we take that click here, and all we do, so as we saw, the click just gives us, really just a unit. And how does it just give us a unit? That might not make a lot of sense. The type of click 1 here, if we look at this, is going to be event T unit. And then what we're doing here, so reading from right to left, the first thing that we want to evaluate is this tpack show, or t.pack dot show, I should say. T denoting that this is coming from the data.text package. And so we're going to fmap that over click. And what are we actually fmapping over? Well, we're fmapping over this functor here. And so events, behaviors, and dynamics are all functors. And if you want to do something where you are, messing with the actual value itself, for example, I'm doing something like this is as basic as we possibly can get, but I'm sure in my future examples, I definitely do. Yes, yeah. That we can fmap over a string or a number, and then what that will cause is that we would have something kind of like this, where we'd have an event t int, and so this event is carrying an int with it, and so we have, then like how we have, monads where we can do stuff to the contained type, but we can also do monadic type level stuff. Sorry, I should say monadic type level stuff, but monadic sort of, you know, functions, um, and the effects of that monad can be exercised. In the same way, we have a much more expressive way, far more ways to deal with events than you would a monad, actually. Um, and that can be difficult to wrap your head around, just how much we can do with events. Everything really revolves around events, and in practice, events carrying important information. Um, yeah, and then we work with these events to determine how this sort of stream of outputted events should affect the value. And so that's some just random deliberation there. Um, but what does this actually do? So we're going to fmap the t.pack.show, which is going to be fmapped over the event and is going to act on the unit. And so this unit, if we were to look at the event at this point in time, what we would see is that this is now a string. And this has to be the case because of this choice here. And so this takes us now into hold dyn. And so hold dyn is kind of the easiest way to sort of start working with dynamics while you're still getting a handle on things. And yeah, there are other ways to make dynamics, but the idea with the dynamic largely is that we have a starting value, this one here, and then we change that value. And we change that value based on the event. And so what this is saying, what hold dyn is doing, is saying that I'm going to keep this value until I receive an event. And sort of the FRP part of it is that this event, what we're writing here is the subscription. We're not writing, this might be obvious, but we're not writing that a click should affect or have a singular effect once or something. We are writing that this hold dyn is subscribed to the lifetime of the event. However, we won't really see that because all we're doing is just going to continually replace with a unit. So we're going to go from an empty string to a unit, 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 to a unit with each and every click. Yeah, so I think we definitely. Oh, we have not drilled that home. And I guess it's important to say that we had to do pack here. Again, it might be obvious. I hope it's obvious by this point. You know, to give me confidence in my past videos, but um, this is text here. So everything in Reflex generally uses text. Um, I don't think there's any instance I can think of where string is used. But yeah. And so, I definitely haven't deliberated enough. We should definitely look at the type of hold dyn, and the type of hold dyn it is type of hold dyn. If I could type, is this here. So this is creating a value. Hence the the dyn in the name. Um, yeah, no joke. I'm not gonna make a joke. But and so what this is doing is create. This is how we are effectively creating a dynamic. And it's the easiest way to create a dynamic. Dynamic. Yeah. Um. And so what can we do with this dynamic? Well, we also have um. Oh, I hate this. It's not gonna show up. You know what? I'm just gonna go back. I hate the search on Chrome compared to Firefox. But I should also mention on that I am using Chrome because there are some issues at the moment with the development environment for Firefox. And the reason for that is that, as I mentioned, with the number of different implementations like iOS and Android, there's another implementation which is JSON Warp, which we are using right now. And so JSON Warp is running on a port, and I don't know what that matters for, but it's a bit more complex of a system to set up, and so for whatever reason, there's a issue with Firefox. I'm not sure about other browsers, but I do know that Chrome for sure works. Anyways, so dyn_text simply takes a dynamic t text, however we procured it, and displays it. And if we now look at what this is going to do, that's weird. It's just going to output right beside. It's going to make a little text node with this element, or sorry, with the unit. And so no matter how many times I click it, nothing interesting is going to happen here. Yeah. And that's because we told it to do that. So yeah. So now this is definitely more interesting, and this is where events kind of become specific to reflex-dom, and in being specific to reflex-dom, it's important to think of reflex-dom as one of many implementations of reflex FRP. For example, there's reflex-SDL, which I mentioned, which you can use for creating an FRP system around SDL2 events, and that's for video games. And anyways, so what we're doing here, and you'll see the def keyword again. What we're doing here is we're starting by creating an input element. We're going to dynamically set attributes of the next DOM element just below it, and we're going to set it based on this input element. That next DOM region, we're going to have a little bit more fun, and we're going to make it a clickable region by the same sort of mechanisms that we saw with button, and we also have some commented out other examples of how to do sort of custom events. And then lastly, what we're going to do is we're going to do some sampling, and so we're going to take the click event of that area, and we're going to sample the original value that we had for our input element, or that we currently, that we currently have for our input element, and we're going to see how that works, because that's now combining everything about event, dynamic, and behavior. And I would say too, in terms of this video, you could definitely get by with this. So, I'm glad that I'm starting with this, but I will be going into a lot more, dynamic ways to work with events and reflex after this point. But yeah, so what happens here? So, reading it like, kind of word by word, reading from right to left, we have, well, really, we should start with def here. And so, what is def? Well, def is going to be determined, or the type of def is going to be determined based on what it's an input to. And so, it's going to be an input to input element. No pun intended, I guess. And so, we saw this in the last video. And so it's going to take an input element config and return us an input element. And so if we look at the input element config, these are the sort of values we can configure it with. And this function is going to take that input element config and turn it into an input element, which might look a little bit more familiar, for non-Haskell developers. And why I say that is because we have, of course, our value of that input element. We can have files, have focus, and we can get information about the actual element itself, which check here. And not very interesting, but well, this is what we're going to be effectively programming in a second. Yeah, and I'm not gonna lie, I haven't used a lot of these really, so I'm not gonna say much about them. But feel free to play around with them and let me know. And so what I'm doing here, so this def, I believe it's a reflex that has or it creates these functions. Yes, it definitely is. I just saw them. And so what these are lenses. And lenses are not something I've talked about at all. I don't think they're necessarily something worth this channel talking about yet. They aren't even honestly something that usually makes sense in my opinion. There's definitely times for lenses, but in my opinion, I have definitely seen them overused, and they, in a way that doesn't really help anyone. But what this is doing is, if we look at input element config, we have this input element config initial value. You can see that this one has an underscore to it, and this one doesn't. And that's because it's a lens. I believe it's actually defined somewhere down here. And yeah, I guess that's just naming convention. I don't really know, but what that does at the end of the day is allow us to set the value of this record. We could, of course, change it like other records we've seen in the past, but I believe I ran into something annoying, and so I just decided I'll show you how to do it this way. And so this is saying set the input element config initial value to red. And I believe that works. It should show, or should render first as a red area. And then what we're going to do, once we create this input element, the only thing that we actually care about from this input element is its value, at least in this case. And so we're going to fmap value. And what is value? Um, value is actually a type, or sorry, a class function. Here we are. And as you can see, it's defined for a lot of these sort of configurable elements. Text area, of course, has a value as well that we can take away. Text area really just being like a bigger, more customizable input box for text. And yeah. So in the case of input element, this works. This is all we really care about in this sense. And just to confirm, we can see that it takes an input element and gets us a value, where a value is, well, you don't really need to understand this. We will talk about type families and their uses in classes. If you are interested right now, there's tons of great documentation out there for type families, although it is a little challenging to understand and see why they are used. But yeah, yeah, and I don't think I'm necessarily the best person to speak on them. But I will do my research and hopefully have a video which helps for the sake of learning reflex. But I've been able to just it doesn't like, and here's the thing, why I've been able to get away without understanding data families perfectly, and data families, type families, very similar. Is this doesn't really even like do much. There's no actual effect that it has on A, and so I just kind of ignore it as a wrapper that doesn't really matter to me. And yeah, it's often still reading the type signatures. It still makes enough sense to see what I need to do. And yeah, so and I'm even using it here, for example. So this gets our value, and even too, by the time that this, I should really call this input L value. This was kind of bothering me before, but I never fixed it. I should really, never mind. I'm pretty sure if we look at the type, and this is one way we can understand what's going on here. The value is already lost. The value constructor is already gone and out of my hair. Whereas if we looked on this side, we would see that the type is going to look like this here. And really, I think I've even looked into it before. What this really means is you can almost think of it as a synonym. That value for input element, the synonym for input element in the sense of value is, well, the value of the value, input element value, which just comes directly comes directly from the actual type itself. So I just don't find it very interesting. Anyways, so now this returns us back to our hold dyn, and we are going to use hold dyn here to create a dynamic, and that dynamic will represent the attributes of our element. And so this, if it's not already obvious, that provides us a way to change the details of that element. We're not going to be changing it from a div to a list item, but we will be changing into attributes, such as the style. And so what I do here is I take this is a bit. So let's break this down. We start with our base adders, which I use the I believe I talk about this before? I did not. So I would have talked about it in the last one though, but I will talk about it here again. This is just basically a way to denote a map. This creates a singleton, and we can map or append these singletons together. Like if I had another attribute of ID with a value of my elem, that's what we would do to create our attributes. And assuming that HTML is well understood, that should make sense. And so we're going to start with our initial values being this, and our background color for the element will be red, and then we're going to change it to verbatim what this is, except a new background color, which we're going to get from our input element. And so all this line actually does, though, is create the adders dynamic. And so if we look at this, the type of this is going to be dynamic t map of text. And so that would not work if that would not work if we were using the functions like ladder, because as you see, ladder takes a static, normal Haskell value of a map for the attributes that it has, whereas this has to take a dynamic, and so we have the function ldynAdder. So let's go into that quickly because there's two. We don't necessarily even have to use the function I'm using here. That's actually to have just a bit more fun. ldynAdder. And so let's start with this one. This being the type signature. Just again allows us to have a dynamic set of attributes. But we go one further, and we're going to use ldynAdder prime. And why is because instead of ldynAdder simply returning this a, ldynAdder prime gives us back that a, the result of the inner monad. Like for example, just to be very clear, like if I said pure 1, and then I extracted this value from the monad, the 1 is equal to 1. And I have given it possession. There we go. Anyways, so now that we have that actual element, we can again subscribe events with that element. Or sorry, rather I should say, we can now program that element to fire events, which other elements or other dynamics may listen to. Dynamics or elements, I should say. And most likely you're going to be using dynamics to create those elements dynamically. So we create the dynamic adders, and we're going to give them to ldynAdder. We lastly give it our monad, which is just going to have some text saying this is a clickable region, and it's going to end with pure. I don't even really need that, come to think of it. So I'm just going to do that. And now that we have this exposed E, we can tell, which can tell reflex how to uh, change the event spec of that element. And so now what this is saying is that if someone clicks this E, then fire the event EV. And EV is going to be used here. And so, and we will come back and look at, once we see the output of this, what, the difference is with these. But we're going to use event with another function, which is very, very useful, tag. And actually, further, current is also quite useful. And so let's start with tag because it shows the reasoning for why we need current. So if we look at tag, what it takes is a behavior, an event, and returns an event. And so this B is just coming from the behavior. So we're sampling the behavior using an event. And so why do we need to sample here, right? Let's dive into that. Why can't an event just do something? And really, that's just because behaviors aren't meant to do that. Yeah. If we turn it into a behavior, we definitely don't want it to be affecting the rest of the event propagation graph. And so all we're going to do here is just simply toss out whatever we have for tag. It could be $1 million, it could be a unit, and we're just going to toss it out and return this event t, event tb, and so the value of this entire statement is going to be something resulting from input element value. So it's going to be a text. This is going to be event t text. So why do we need current? And it's really to fit it into this this function here. If I was to guess why tag asked for a behavior as opposed to a dynamic, I imagine it's just simply that a behavior is a lot. A behavior kind of, in a sense, returns to I guess purity, if you want to call it that. It's not really purity, but you know, a behavior has a very definite value, whereas a dynamic is changing, and we're programming it in a way that we're expecting it to change and handling that change. But here, all we want to do is just get the value. We just care about what this B is. So let's wrap it in a behavior and make sure that it's not going to change. And so that's why we have this entire line here. Now with color capped is now an event, because this is an event, and so we can give it as an input to hold dyn. So hold dyn is going to start up with just minding me own business, and is going to change to whatever color capped gives it. And so what color capped is going to give it, as we'll see in a second, is going to be the input from here. And it's only going to even do that. So it's not going to, you might be tempted to think that if we enter a new value into this input element, that this is going to fire. This will not fire because what we're subscribing to is tag. And so tag, and even too, because this is eventually becoming, in this event propagation, this is just becoming a behavior, right? This is just resulting in a behavior with the current input L value. Right, and so we can have this input element which receives user actions, me typing, another character, um, and and that actually produces an event we can subscribe to. We can check every single time that the input element is updated, and actually we do that here. But we're not doing that here. We're instead reducing it to a behavior so that we can control when we take on and when we actually use that behavior. And so that will make sense in a second. But this will change once we actually click that area. And so this should now be running. So it starts out with red. And so if I go like that, it now has updated because of my user event. And this is going to mean that RE is the value here, which is not a background color. But if we change this to blue, as soon as I type in this E, and specifically that E, this will now match being a CSS color, and we see the region turn to blue. But we still see just minding my own business because this event has not happened. So if I now click this, it turns to blue. If I change this to magenta, it turns to magenta once I click. And yeah. And so now, again, this is not like we didn't, solve quantum entanglement or whatever, but I hope you can imagine as of now how with the strong type guarantees that we have, and of course you guys kind of missed the work I had to go through to make this actually type check, but this is now going to work. This is just going to work. There's no possible value I can give for this that it will not behave as I expect. Permitting someone gives a very strange, weird color that I just don't like the color. That kind of behavior, I guess, you got me there. But the actual structure of what's going on with the event propagation graph is always going to work, right? As long as it type checks in this case, is always going to work. And that is extremely, extremely powerful as we get to more annoying implementations. Like I said, I have a WebRTC implementation, which I'll be honest, I did pretty brutally fast, and it could be better. Well, because there are some more advanced concepts to that, which we will go through. And I still need to actually, even though we're going to talk about these concepts today, I still need to actually implement them myself in that specific case. But yeah, the point is, I think it is definitely exciting how easy this was to make something that is going to work no matter what. There's no possible value you could give, and try to break this. Try to make more complicated cases, especially if you're dropping off out of the video now and not sticking around. Sorry to see you go. But try to make as complicated as an event propagation as you possibly can. You can only get so complicated, really, but you will never run into the same problems that you could with JavaScript. If I was to start, opening up the web console here and, start programming this, fixing the, writing the scripts directly in here, then, just it would be very easy to screw up. And I think we can all agree on that. No matter how good of a JavaScript developer you are, you definitely make mistakes. And I prefer my mistakes. My steaks. I also prefer steaks, yes. But I prefer my mistakes to be served like a steak right here in my console where I can clearly see what I've done wrong, never have a false positive, uh, and then continue on. Whew. Oh, and I guess I also forgot to say that I just put this all to upper, and that's why that's to upper. But yeah, not really reflex. Um, yeah. So now, and really, what the rest of the lesson is focusing on is just different variations of what you might see. I just want to give a bunch of examples that are helpful. And yeah, and as we'll see, they're all very simple, no matter how complex the actual event propagation graph that we want to do is. It's very linear almost, I want to say. But so we have now two sources, and let's look at this refresh. So we can click me or me, and we have this empty string here. And so why do we have that empty string? Well, if you can guess, it's because we have hold 9 empty string. If I change this to that, change this to that, of course. And so now what we're going to do is we're going to merge two events. And so we could continue to add to this. We could have 9 events here. And you know what? Let's add a third one. Let's do click C. Um, oh, and this brings up a good point, which I don't know if we've actually gotten to, surprisingly. Yeah, I guess we haven't gotten to this. So you'll see this function, and this is nothing. This is nothing special to reflex. This is really just like a dumb functor, or sorry, dumb fmap. Um, and so if we look at this very quickly, we can see that all it's doing is replacing the contained B with an A, right? And so this click A is not. You might be tempted to think that it's carrying the text of click me, but is in fact just carrying a silly, stupid, annoying, awful, useless unit. And so then we're just going to replace that unit with hi. Um, or by or wait. And what this is going to do is just create a dynamic, right? So we go from 3 separate buttons, which each emit an event. We have a dynamic, which is subscribed to all 3 of those events. And then we have a way of dealing with merging the multiple subscriptions. Right, so this would be very simple, very straightforward if we only cared about click A, right? If we had hi, click A, and then we had this, right? That type checks. Except that is not very interesting. So we're going to instead merge together 3 different events. And so we're going to do that with merge with const. In terms of why I'm using merge with const here, truth be told, I do not honestly recall. I learned this was the best way to go about things. I'm a little confused because I was told not to use leftmost, but if I look at leftmost, it's merged with const. So I don't know. I mean, feel free to use leftmost. You will see it in most tutorials. Um, and yeah, I'm committed to using merge with const because apparently there's a reason, but I can't imagine why there's a reason. I could be missing something, and I don't know or honestly care. Um, so yeah, so this merges these into a singular event, and I suppose we should look at merge with right here. And so const fits this because const just takes the first of the two. And this will fire for any event, as we will see. So I'm a little confused with how the const works, but I don't know. Yeah. And so it takes a list of events and folds them into a singular event that we can work with. And we'll type check and fit into our other functions. And of course, we already know how hold_dyn works, so it's now just listening to that merged event. I've just called it multiple sources to make it distinguished from the other ones that I had before uncommented. And then this is just going to write a dyn text. So if we look at this, we now have a third button. So we're going to say click me, hi. Okay, that was weird. Whew, that confused the heck out of me. I thought I was wrong about the merge with const for a second, but I am right, as always. I'm just kidding. More often wrong, but yeah. Enough philosophy. So, yeah, that's what we're just doing, and this will just continually update based on the last event that it received. And it will be specifically updating this here. And so just a by the way, I mentioned before, the differences between imperative and FRP, and how I actually came to learn that was that I was originally thinking of reflex in an imperative way, and it really just messed up how I viewed functions. So it might be best, most likely, definitely, 100% is best to think from the perspective of this dyn text, and view it as the output of this dyn text is affected by these three factors. And now more in terms of the code, this dynamic that we're generating is affected by these three factors, which may or may not happen, right? And that's why it's best to think from the output, is because an event may or may not happen. Interestingly enough, too, if you do look at the reflex timeline implementation, reflex class implementation, like literally reflex t, and you look at it for the pure instance, you will see that behavior by dynamic and event are defined using maybe. And that, now if I recall why that is that an event may just stop propagating. There might be something that stops it or filters it out from continuing to propagate. And yeah. And so, especially the other side of things is that no matter how complicated this gets, all we really need to do to add another input here is just add another line to subscribe to. And so that's just very, very straightforward. And, we could have something that does actually do something, takes the events and merges them in an interesting way. Although I think I'm actually thinking something else. So and yeah, you know what? Actually, I'm thinking something else that is, I believe, the next thing we'll be talking about. Yes, it is. So I'm just going to do this quick. So the next thing we'll be talking about is thinking about thinking about events as an input stream. And so we had the rock example where, over time the rock. Let me see if I can pull that up really quick. I should be able to. Over time, the rock is affected by different factors, and we sort of accumulate. Actually, and I guess this perfectly fits the problem. Is that we are accumulating displacement. So, we are, and we're doing so by folding in a number of forces that have moved this rock around. And I believe we have, maybe didn't autosave. Whatever. But, the point being that, we can view these events as just a typical input stream. And so, here is something we've done with an accumulator, and the easiest example to think of with an accumulator is just a list. Now we can, do more interesting things than just add things to a list, and maybe we'll edit this in a second to do that. Yeah, you know what? Let's do that. Let's do that. It won't be much more interesting, but yeah. And so all this is doing is taking, well, we have a click, and every single time we have that click, we are just, you know, F mapping in a sense, hey over that click, so you end up with an event t text, and that event t text is being given to a cum dyn, and so cum dyn just takes a function which merges an A and a B into an A, where A is our original input that we start with. So as we can see here, it is a empty list. And then, the B is coming from the event, which leaves us with a dynamic TA, where that A is yet again the original element that we started with. And so nothing about that forces it to be a list by any means. But it's very visual what is going to happen here. Yeah. And all I'm doing here is I'm just showing the list as a whole. Hey, how's it going? Yeah. And so now let's make this a little bit more interesting. I'm going to instead append this, and it's just going to be one long string. And what I'm trying to show here is that we are adding together the values, and we will get to a slightly more interesting case in a hot second. I just don't want to mess with that. That's not really anything to worry about. That's actually to do with the JSaddle. Did I call it JSaddle warp? I think I hope I called it JSaddle warp. But yeah. So now we're just continually building a string and concatenating to that string as we go along. And we could have something that does some more logic, like let's say if length of y and x is greater than 20, then woohoo, else y, x, and weird. What? I feel like that should work, but I'm just doing something stupid. Um, okay, let me figure this out quick. It's not just this. Oh, this might make sense. Oh, okay. Because I have to do. Oh, right. I have to use length from text, I believe. There we go. And so now what this is going to do, well, let's check it out. Cool. So some, and of course, my imagination is kind of absolute bunk right now, but go absolutely nuts with that. Get creative there. And so continuing on, I should talk about fold, dine, and count, which is really just, yeah, I mean, very, very much verbatim what we're doing here with the cum dine. It's pretty much a cum dine and fold dine are pretty much just flipped arguments. If we look at the type of a cum dine, it's A to B to A, whereas the other fold dine is A to B to B. So, yeah, exact same result that you're going to get. Both create a dine by folding over a series of events, right? Um, and what's cool about that is that these events are happening over time, but we're still folding over them. And so I tend to think that's pretty cool. So I'm just going to change that now. And so what I'm doing here is I'm first just implementing count in a very simple way, in a very crappy way probably. And I'm just going to throw 1 over the click 2, so this becomes an event t int, and then that is going to be folded into this 0, or the result of the dynamic at that point in time. And so 1 click, this is going to become 1, 2 clicks, 2, 3 clicks, 3, 500 clicks, 500. And then we're going to pack and show. Pack it up, so to speak. Yeah. So. Oh, that's why. I was wondering. I was like, why is it going up by 11? And it's just because these are two different text elements that are each being updated at the same time. So crazy. Um, but yeah, I bet you count even is very similar implementation, but just a little bit cleaner. Um, now what's this one? I'm not gonna lie, I can't remember what I did here. Um, oh yeah, and so continuing to build on the idea of events as streams, we have two functions, head e and tail e. And so what do they do? Because events aren't, actually a list, right? Head being something you might know of from lists, not from anything else. Get your mind out of the gutter. Or tail from chasing tail, or from also the function of tail. Yeah. And so, how does it work for events? Well, this head function is going to get the first event, and no more. Uh, the second function, um, tail, is going to give us everything but the first event. And so now let's check this out. Actually, I don't think I even watched this go. Come to think of it. Oh, well, actually, no, never mind. I know which one it was. I had all of them kind of just displayed before, and yeah. Oh, these are still showing. So let's do that. And so what should happen is that click 1 is being used for this fold line, and this is, again, just verbatim exactly what we had here. Not trying to change anything in that sense. And it's going to show through this dyn text. So we're going to show the dyn text of A first, or the result of click 1, which is going to be head E. So we should see this change once, and then on that, when that happens, this second one will not change at all, because we're dealing with the first part of it. And then from then on, this should be stuck at 1, and this will go to whatever, infinity. So there was our head E, and now we see tail taking shape. And so there's a number of functions to do stuff like this that I wanted to show you. Cool. So I actually created this before. I made the original one with the input element, and so this is not as useful. But does this show? Well, the next one shows gaining on a behavior. I mean, what is new here? I will say is the constant, the use of constant, and what does this actually do here? I don't know. You know what? I honestly don't even remember. And I don't want to spend time on it, so I believe what's sample 2 then doing? It's on me. It's not happening. Huh. Okay. What? I I don't know. Um it's weird. I don't know. I don't really care for this. This is kind of a Yeah, I shouldn't have even spent time on that. And not because I'm trying to avoid looking like an idiot or something. I look like that by default. But I don't know what I did there, because yeah, that just surprises me. Um, oh well. Um, not I don't think there's any value in me trying to pick that apart right now, because it's probably just something stupid. And it's even very similar to what we did before. So I don't know why. I don't know. Now, uh, what I have done here is I've created an event which will never actually fire. Or, well, I shouldn't say that. That's very misleading. It will fire, but it will never reach its target. Um, right? And so the dying text D is subscribed to an event which gates the original event. And by using constant, I have created a behavior T bool, which is going to be always set to false. So this is never, ever going to allow the original event to propagate. And how I've done this is, well, by using the gate function. And so gate takes a behavior T bool and an event. And so let's look at that function quick, because it is pretty useful. And so this is the function here. And so if this is if the value is true at the time of occurrence, and again, this can be based on more interesting things like based on a dynamic, as we saw with sampling the value of the input. For example, we could have going back to that example with the input element, we could simply have something which checks if the supplied color is a primary color, and only if it's a primary color, RGB. I hope that I'm right on that. I don't know. It's been a while since grade school. But if it's a primary color, then actually do go ahead and change the value of the attributes and the style tag, therefore. But yeah, so. But here, I've just simply set it to false, so you can see that this will never. I think we can all agree at this point that this will actually fire an event whenever I click the button, but that's just being stopped. Hence the "come at me, bro." So, good luck. I guess we are not gonna get into a fight today with them. So, yeah. And so gate is definitely an extremely useful function that I use a lot. For a great example of gate is web requests, actually, which we will cover in a future video. But an event which we would have, which can create a web request, we wouldn't want it to create too many web requests. And so it would be best to check if we have already sent one. And so if we've sent one, we are going to create a dynamic, which is going to a dynamic of what's currently going on. Are we currently making a web request? And if we are making that web request, well, we're going to sample that, get that as a behavior, and as a behavior T bool, and then we can gate the web request itself by whether or not the web request is working. And so that would look at something like, gate is request, in progress, and then, fire request, where these are some high-level functions that where this is actually doing the logic of the XHR, or sorry, the web request event, I should say more generally. And this is checking if there's a request in progress, and of course it's just going to be of the type behavior t bool. This really makes me think I should definitely have like another window up here just so I can write as much pseudocode as I want and no one can stop me. Yes. Yeah. And so that's an actual true use case of gate. Very useful function. And so what is this one here? What do we do here? Oh yeah. So I'm just, the second example really illustrated a lot of different pieces that I had outlined. But quickly here, what I wanted to demonstrate was updated. And so this is going to update, even though the actual value that we're going to get is never going to change. Like if we look at this, the whole dyne is always going to be, resulting in a event t unit. Yes, it will, and I suppose this is technically quite important. It will be a new unit, but it's also not really important because it's a new event. Is what matters. And so because there's a new event, despite there not really being a exciting new value, there is still an update happening here. This whole dyne is continuously updating the dynamic that is created. And so every single time, and this take me out for dinner is the dynamic in question, and updated just simply checks, takes the dynamic TA and fires an event anytime that it does update. And that event is carrying what is in the dynamic. And so this is actually extremely useful for a number of reasons. Extremely useful for a number of reasons. A new value has arisen, and so update the rest of the DOM in every place that that value exists. And we're doing that through event propagation. Yeah, and in a very neat, clean way. We also have the function of toggle, which actually makes this an interesting, sort of event flow here. Otherwise, not much would be happening. And so if we look at this, what I do? Oh, yes, and it is right. I should have. That was actually a dynamic, not a an event. My apologies. Um, so this is now just going to toggle every single time there's a click, and of course, we could just do a toggle very simply based on clickety. This will work as well. And there's not going to be any change, but the point that I was hoping to make before I no longer needed to make it really was that about what is going on with updated, even though the actual value itself might not be updating or look like it's updating, and really not updating, continually staying the same. And so this last one is, oh, sorry, not last one. We're actually about to get to some more complicated stuff, but and about as complicated as it gets, but still very clean and an implementation which is not going to break. I can't imagine trying to do this implementation in plain JavaScript. I suppose I could figure it out, but I don't want to. So why would I? Yeah, and it'll probably break for a couple times, and It'd be a lot longer than I expect. So this seems like the sort of path of least resistance. But anyways, so what we have here is an event, a button, event from a button. We're gonna fold in really what is just count the event, add one each time that happens, um, and we are checking if it updated, and then what we're gonna do is we're gonna do a check on the updated value. And so what this is doing is seeing if x is less than 10. So if x is less than 10, return just x. So do propagate the event. And if it's not, don't propagate the event, is effectively what this is saying. And then what that does, and we use this, we actually make this happen through the map maybe function, which is a part of a sort of family of functions right at the bottom here. We could have very much just used filter, and I could have made this a bool, but I wanted to show map maybe, and this is coming from the filterable library, which is a very awesome utility. Or sorry, witherable. Very awesome utility. And it makes sense too when we think back to the pure reflex timeline, which is implemented using maybe to signal whether or not an event should propagate. And so then we're going to display it. So without further ado, let's look at this. And so if x is less than 10, then do propagate the event. So now what's happening is that, I guess we've clicked it a couple times since then, but the value of dyne has to be something like 13. And now it's at 20. Now it's at 20 million because I click so fast. I'm kind of talented for that. And but it doesn't matter because those events are going to get filtered out by our map maybe function. Which is really, and so reflex is just upgrading this maybe to the event not firing at all, which is kind of cool. So now we get into switches, and I'm just going to be brutally honest. I haven't actually done one of these myself, and so I basically adapted this from the Queensland Functional Programming. Do I still have it open? No, I do not. I do not. But so I definitely recommend checking that out. Maybe I will definitely, out of not stealing their work, put their link in the description. And like I said, there's many great tutorials out there for reflex. This is just to provide another sort of learning tool or path. And so what this is doing here, and this is quite complicated, but still actually quite simple for what we're doing. And so what we are doing is, let's start by showing. So I click this, and by default it's going to add, you know what, I'm going to make a little buffer here. And so this is going to continually add to that. What happens if I click this? Okay, it's going to continue to add to that. Nothing happening here. But if I now click this, and I click this button, which was before affecting this, it's no longer affecting this, or sorry, affecting 27. It's now affecting the left output. And so how are we actually doing that? Well, let's work backwards. So this is our output on the left. This is our output on the right. And so I guess we'd have to look at how the events work. And so 2 is just a count on how many times 2 happens. What is 2? Okay, so 2 is this now complicated thing of switch hold, add, merge with const. Yeah. And honestly, all I did, by the way, from changing it from the Queensland tutorial was just change this from leftmost to this. Shame I no have. Well, yeah, no, never mind. And so what this is saying is, so this is going to merge these events, and if we look here, add is an event, C2 is an event, C1 is an event, never is an event. Okay, so how would this look for a previous, well, a previous merge with const? Let's start there. Merge with const of a list of events would give us back one event. And so we're either going to have the event of add or the event of never. And so, and you know what, I'll be honest, they're definitely going to have a better explanation than I will, because this is kind of crazy stuff, but what this is saying, so add is the first event outputted of the 2 will start by being the value of add. So like how we have hold 9, which has an initial value and takes in a list of events, which will change this value. What we now have instead is a list of events which wrap events. Right? So add f mapping over C2. C2 is going to start as event t tuple, or unit rather, and then we're going to f map add, which itself is an event, right? So we're going to, say event t, and that's going to replace the unit. So we end up with event t unit, because that's what we have f mapped over. And that results in this event t. And we have a list of these event t's. And so that is now where switch hold comes in. Because what switch hold is going to do is it quite literally hold dine, but for events. And so let's look at the type of switch hold. If I could ever type it in to find it. And that's exactly what it's expecting. So it switches to the new event whenever it receives one. Only the old event is considered the moment a new one is switched in. And we end up with this behavior where I select either 2, right? And so 2, this literally pertains to this here. And so if I click on C2, what happens? Well, C2 has two things which are subscribing to it. Both of these switch holds subscribe to C1 and C2, right? So add is really add is not necessarily affecting anything about the behavior of this switch hold. It is just the value. Same with never, right? We're not using never or add to do anything changing anything in this region. But rather they are outputs. So how this reads is that if C1 happens, well, let's think about this. If we press C1, what happens in this chunk? So this chunk will execute with that information that an event is fired, and we will, fmap add C1 over there, and it will fire. So this will ultimately be our event of this merge with const. And so we have switch hold never, in the sense that we started with, outputting to the second one over the first, and you can see this is flipped, that we started by adding to the second one. And so this means that that 1 is going to be add if C1 is clicked last. This is pseudocode, of course. Hope you know that by now. Wait, why am I having an issue? Oh, with this. And likewise for the other one, this is just going to check which of C2 or C1 fired. They could fire at the same time. And, then I guess, merge with would not be what we want to use. We would want to use something of leftmost or coincidence, where leftmost would take the if so allegedly the difference with leftmost is that it would take the first event to fire in that list, which is why it is called leftmost. And so in this case, if looking at this here, if C1 fired and C2 fired at the exact same time, and again, we're explicitly modeling time because it's FRP, then we would see that add would be the resulting event that we choose. And same with this. So, gotta lick my lips or something. Apologies. Oh, yeah, no, that's also pseudocode. And so we're gonna count the times. So this is effectively counting the times that that we have, I guess if you want to call it set add to set 1 to subscribe to add rather, and for 2 set 2 to subscribe to add. And this add button is what does all the actual magic of adding, or adding to the pile. Yeah, and so that is why we see that resulting behavior. Pretty cool. Yeah. And so there's a longer explanation about it for the Queensland Functional Programming Lab, I believe it's called, QFPL. Anyways, link in description. But lastly, should talk about identity cases and just mention that there are such things as time-dependent cases. We talked quickly about coincidence, where two events are happening we didn't. But I believe that leftmost is implemented with using coincidence, or something like that. You know what? I don't know. I just think I just read that wrong. And the easiest example is now, which literally fires at whatever time the DOM builder sees that event. Um, and it's a very easy event to subscribe to, but I wouldn't overuse it. Um, yeah, or do, I don't know. A line event with maybe is a way which we can get more complicated with how we merge our events together. Um, and I won't dive into that because there is a bit more to it that I think is out of scope for this lesson. But and then we just have our identity cases. We saw never, and what never is an event that never fires. Um, yeah. So going back to this, if we instead of using never had add or another add to, then we would just see different behavior. Um, yeah. And so um, constant we've already seen, and constine um, is basically just like constant, except is really just for the sake of type origami. To my understanding, cases where you do want a constant um, in the event propagation um, sense, but you have to, for some reason, provide a dynamic. And so this allows you to kind of downgrade it from a dynamic to a behavior in a sort of trick. I believe it's a trick. I don't know. But then that is all to talk about. Oh no! Oh my gosh! I I just realized I completely glossed over these two. Um, so, just very quickly, um, dang it. Um, so, what I was trying to show with this line here is that we have a number of options. Oh my gosh, did I drop the ball or what? Ah. So we can use the DOM event to subscribe to any of these events, and I'll leave them here. They don't really deserve much of an explanation. They are pretty simple. They're just different DOM events that can happen, and so we can choose to subscribe to any of those. We also have the key press function, which is a very similar thing, in that we're subscribing to a key. So someone presses enter on our page, and let's see what happens with that. Yeah, I need to change this. Hmm. Oh, crap. I actually haven't used keypress in a long time, but I believe that I have to use it for this input element here. Um, or I'm just doing something stupid. But either way, I guess I'm just going to cut that part out. Um, you know, maybe I'll say that's homework for you to figure out. But yeah. I can't believe I dropped the ball like that. Whatever. Um, hmm. Anyways, I'm gonna yeah. Hate to end it on a note about my stupidity, but oh well. So I hope you enjoyed the video. Otherwise, apologies for the little blunder I'm having here. Um, but I believe that this is to do with input elements. Um, and so stay tuned for my next videos on the rest of the sort of reflex library and FRP. Thank you so much for watching, and I hope you have a great morning, afternoon, night, whenever you like to code.